This is just a short screen recording using the PhET simulations online to demonstrate thermal equilibrium. So in this little simulation, we have, I'm going to click this here to show the energy symbols. So think of these little red blocks representing the amount of energy that these materials store. So we've got a block of iron, we've got a brick, we've got a container of water and a container of olive oil. For this demo, I'm just going to use the iron and the water. So I'm going to put the water up here, and I'm going to cool it. And I'm going to put the iron block here, and I'm going to warm it up. Feel free to play around with the simulator on your own. So I can turn up the heat, and you can see the energy is being transferred from the heater to that block of iron. Those little E's represent energy packets, and you'll see some of those energy packets are going to be lost to the surrounding air. Okay, maybe not in this, there we go. So some of the heat is lost to the surroundings, but a lot of it is absorbed by the iron, and the temperature of the iron is going up. Actually, I'm going to reset this. So I'm just recording this short video demonstration of, or visualization of thermal equilibrium using the PhET simulator activity online that's called Energy Forms and Changes, and you can feel free to play with this simulator as well. So I'm going to put my face up here. So in this simulator, we've got four materials. We've got a block of iron, we've got a brick, we've got a container of water, and a container of olive oil. I'm just going to play with the iron and the water in this simulation. So first I'm going to show you, put a thermometer on each of these so that we can get a temperature reading on the water and on the iron. All right, and they are equal right now because they are both at this room temperature, ambient temperature here. But now I'm going to put the iron on this heater here, and I'm going to put the water here, and I'm going to heat up the iron and I'm going to cool down the water. I'm also going to click this little tab here so that we can see the energy represented as these little packets within each of these materials. So you can see that when I heat the iron, the energy is transferred from the flame to the iron, and you can see the temperature of the iron block rising. So we're going to get it nice and hot. Get that temperature up. Lots of energy going in there, so it's holding on, it's storing the energy. Some of it is escaping and releasing into the surroundings, but a lot of it is being retained in the material. And on the flip side, I'm going to take that water and I'm actually going to cool it down. And you'll see that when we cool something, what we're doing is actually taking heat away. We're actually taking energy away from it. So energy is being transferred, in this case, from the water to the ice. Okay, so the water is cooled down, the iron is heated up, the iron has lost a little heat while it was sitting there. I'm going to just give it a little bit more. All right, and when we put this block of iron in the water, energy is going to be transferred from the iron to the water until they're at equal temperatures. So watch the thermometers. So the water temperature is going up, the iron temperature is going down. Notice the water temperature goes up fairly slowly while the iron temperature comes down fairly quickly, and that has to do with the differences in their specific heat capacities. Water can hold a lot more energy without raising its temperature than iron can.